I encourage you to read that, because all I'm doing today is really, for the most part, correcting some misunderstandings that came out of that talk, which are not Russ's fault. So first of all, history. Go started as a name in 2007. In fact, in just about a month from now, it will be exactly 10 years since I threw up my hands in despair and said to Robert, do you want to help me do something? So 5 years after that was Go 1, which if you look at any sort of adoption curve, has a severe knee, because that was when we stopped breaking everything and started promising people that Go would be stable and people could use it in production, and it had a profound effect on the upkeep. At his talk, Russ said he thinks, by fairly careful analysis, but somewhat imprecise, there's probably at least 500,000 Go programmers in the world. That's pretty amazing. Now, when you have stability, and we said this when we released Go 1, 1.0, the first version of a released version for stability, that we were not going to change the language very much, that we were going to try to keep things stable and focus on using it rather than changing it, and learning from using it, so that when it came time to have Go 2, hypothetically, we would know a lot more about what worked and what didn't work, and we know how to change. And we've now reached that point. It's 5 years on, and so now we're thinking about, okay, what have we learned, and what does it mean? Well, first thing to say, most important, is in this process, nothing's really changing at some level, because the goals are the same. We still care most about things like the effectiveness of the language and the tooling, the libraries, how well it scales, how productive people are working in the language, keeping compatibility up. I think Go has probably set a record for the most compatible, backwards compatible language in a long time, because as far as I can tell, nobody tells us our stuff breaks very often unless there's some bug that came up. We don't break stuff just for fun. We break stuff only when we made a mistake. And also the community. The community is a huge part of this. We don't want to lose the community. I don't need to name languages like Python 3 or Perl 6 to talk about what happens when language communities try to make a big change. And so you can probably guess we're not really talking about a big change here. We're talking about something that is not necessarily going to be exactly compatible with Go today, but the transition is not going to break everybody. That would be a disaster and go completely against the ideas that have made Go succeed so far. So you don't need to worry about it, but what do you want to think about? The trick here then is to maintain those goals, make sure that we maintain effectiveness and stability and so on, but actually improve the language in ways that actually matter. And if we're going to do this by asking everyone to think about the experiences they've had using Go. And as I said when we mentioned Go 1, as we said back when we released Go 1, what we want to do is to learn from the time that we spent using this pretty stable language and figure out what doesn't work and fix that. We're not interested in hypotheticals. We want actual, real answers to real questions that have occurred using the language for real. So Russ coined this term called experience report. What we're looking for in order to guide this process, and remember, we are not saying here's what Go2 is going to be. What we're saying is here's the process by which we're going to figure out what Go2 is going to be. And that process is based on what Russ is calling experience reports, which are reports from the community of using Go that didn't work for whatever reason. And he has some examples in the talk. There are lots more, as you'll see. An interesting one that many of you might not know was when Go 1 was released, we made a big change, which was we introduced for the first time a standard interface type into the built-in namespace. And that, of course, is called error. Now, it replaced something that was there before called os.error. And os.error was pretty much the same as error. It was slightly different, but it doesn't really matter what the difference is. But it had this problem that you couldn't use os.error from any package that OS imported. So there was a dependency problem. And that struck us as a really nasty thing, because we wanted to call, who knows, bytes, strings, whatever, from the OS package, and they couldn't use the same interface definition. So they could have their own version of it. They couldn't use an important one. So this is an interesting one for me personally, because I was in the room while this was happening, but also because the answer was actually suggested by Raj Pepi, an external gopher, who convinced us to introduce something we hadn't had before, which was a predefined interface. And so that, of course, had a huge effect on cleaning up the language in a big way. Whatever you think about error, dependency, and management, and so on, changing from OS.error to a built-in error type was a huge win that was triggered by thinking about the problem, understanding what was wrong, what wasn't working, and getting the community to say, you know what, think guys, this is what you want to do, and we did that. Yeah, it's great. I think Dave already mentioned the leap seconds problem that happened at Cloudflare. There was a very bad outage that they had that was caused by the Go time package not being any good. You can criticize the Go team for not responding preemptively to that, waiting for a production outage. But the fact is that in retrospect, that production outage was a really good experience report. Hey guys, your language couldn't do this, it broke us, you should fix it. And that was a really good problem to look at, and we came up with a solution. Well, Russ came up with a really good solution. I think actually a very clever one. Another one, which Dave also talked about, which has gone on for longer than Dave implied, is alias declarations, which were introduced not because it was some arbitrary Google problem, which was what the problem was presented as the first time around, but instead to deal with this fairly deep problem, which is when you have a very large project and you want to refactor it. The language already had the tools to let you refactor constants and variables and functions, but there was no way to refactor types. And so it made it very difficult to do incremental changes while you're refactoring and redesigning code. And alias declarations were introduced specifically to solve that problem based on problems we had seen with multi-million line code bases that could not be refactored. Maybe they're wrong, but I don't know. That wasn't my point. And here's the point. Here's the real point. You probably, many of you have had a situation in production or maybe just in your day-to-day work where you said, I wish if Go hadn't had this issue in it, then Mike wouldn't have had this problem. And if this small thing were changed or this big thing were changed, the problem would never occur in the first place. So that's really what this is about. It's a call for experience reports. Now, I want to stress a couple of things here. Number one, we're not just talking about the language. This is not a request for language features. Go is not just a language. It's got a bunch of libraries, it's got tools, it's got a community. What in all of those things is wrong and not working for you? Maybe you don't like the hairstyles that people in the Go community have, and it stops you being able to work in the morning. Write an experience report about that, whatever it is, right? The point is, don't just think about this as a request for what should we do to the language. We're trying to think about the entire ecosystem for Go and change it as an ecosystem, not just by adding a feature to the first page of the release notes, okay? And most importantly at all, it's really, really important. We want this to be community-driven. Even the core Go team doesn't want to sit in the room and figure this out because we don't know what you're all doing. You have to tell us, and tell us what's good and what's bad. And this all comes back to this question about what is it? Is it the language? Is it the library? Is it the tool? Is it whatever? I've said this before, and I should probably say it more often. Knowing where to solve a problem is at least as important as knowing what to do. Sometimes, if you're a compiler writer, every problem is a compiler problem. If you're a library writer, every problem goes in a library. But the community uses all these things, and they know where the real problems are and what should be done. So have to let us know. So I also want to stress, because this is a message that didn't really get across there, we are not looking for lists of features. We're not asking you to tell us what we might do. We know what we might do. We have an issue tracker. It's full of proposals and suggestions and bug reports. The question is not what would we do, what could we do, but what should we do? That's the trick. We're not looking for, hey, this would be really cool kind of suggestions. We need problems that you've had, not even necessarily solutions to those problems. If you've got an experience report that ends with, this was screwed, we don't know what to do about it, that's really helpful. That's good information. That's much more information than saying, here's a really cool way to solve a problem. Maybe it'd be useful than it really is. That's not helpful. There's this thing people say a lot, which is, this feature would be really useful. And my response to that is, of course it's useful. If it wasn't useful, you wouldn't call it a feature. So don't say this feature will be useful. Instead say, here's what doesn't work. Here's what happened in my world because this is not working. And if you have an idea, here's what you should do about that. Okay? Now how do you do that? I missed something. Where did my link go? There it is. Sorry, I missed this link at the bottom. There's a wiki page now called Experience Reports. It's quite large. It's got a lot of things on it. Not all of them are good. There's a few really interesting ones, though. I encourage you to take a look at that. Think about what they're talking about. See if any of it makes sense to you. And most important, if you've got something that you think should go there, by all means, write it up, link to it, and we'll talk about it. Okay, now, we're going to have a little panel session. Your panelists today are Dave, myself, Dave Simons, who's a Google Skype, and Manish, who's here, yep, and we'll be happy to talk to you there. So I'd say don't ask me questions. Instead, we'll switch to the panel, do it that way, and let you guys respond there. How does that sound?
Yep.
All right. Cool. So maybe we should start by introducing ourselves. Those of you who know us, I think most of you know me and Dave, but maybe Dave, this Dave, and Manish should introduce himself.
You go first, Manish. Hi guys.
You have to press the button. Green.
Keep it pressed.
No. Make it green.
Is this on?
Dave's is on.
Hold up your mic and say something.
Manish.
Hi guys. I'm Manish. I'm an Googler and now working on dgraph and we built Azure, so really deep into using Go. I've been using it for at least four years now.
Okay, yeah, my name's David. For those who haven't met me, I used to organise this meetup. I was involved in organising GopherCon as well, and yeah, I've been a contributor for a couple of years now.
My name's David Simons. I work at Google. I've contributed to Go since about 2008 in various forms. I sadly don't get to use it as much as I do these days. I'm stuck with C++.
I'm Ross Mike. I'm one of the people responsible for getting in the room, which makes me very happy. Thank you. So why don't we just throw it out to a Q&A? Just make sure that, I guess we need mics maybe. We'll repeat the question. So.
Do you want me to run around with the mic?
I'll make sure.
If you don't mind, use this mic. We will share.
Yeah?
Yeah.
Here's the third one. We have three up here.
They are.
Keep on the pass back and forth. Yeah.
You go that side, I go this side.
Sure.
Cheers.
Okay, don't be shy.
I've got the mic, so I'm gonna.
Gary?
Hi.
No,
I've
go.
got a question.
Mic. Is this gonna cause feedback?
Good for
Is the green light on the mic?
Nah, so I've got my last question. What's different between Go 2 and Go 1 point whatever number it gets to? Are there breaking changes that you're looking at?
Let me give you an example. The answer is that Go 1 dot whatever will be Go 2. We don't know what whatever is yet. We don't want to split and have a Python 2, Python 3 kind of situation. That's actually the opposite of what we'd like to have here. There may well be breaking changes, but we'll do it in a way where we can transition people so that it'll work. And the hope, in fact, is that we don't have to break people at all, because the compiler and the tooling will recognize this is a Go 1 file, this is a Go 2 file, and we'll make them work together. You won't have the kind of versioning issues most people have. An example of what kind of thing we're thinking about is the random package, math_rand, has a property that we required somewhat accidentally, that it be rigorous in the set of bits it generates, so that people can depend on the sequence of numbers that come out of it. And we've since figured out that, in fact, the generator in math_rand is not a good one at all. It should be replaced for a lot of reasons. And some of us have been working in the background on trying to make a better generator. Rolling out a new generator is going to require that the bits change. So that's a breaking change. But we're going to try to do it in a way that the transition means you don't have to deal with the breakage. You can take care of it, you can deal with the old one, you can deal with the new one, but fundamentally when you're done, you'll have the same API, it'll feel like the same package, but now you're using the right kind of bits. That's a pretty low-level detail, but it's an example of the kind of thing we're thinking about. Now, there may be some breaking changes. Don't know yet, because you haven't told us what needs to change. But the hope is that breakages will be small in number, but not necessarily in effect.
I just have a question. Maybe it's kind of related to something that I was reading a year ago. Jason, Marshall, performance. Why so many implementations? The unsafe package. Does that ring a bell? Like the normal implementation seems to be underperformed compared to implementations made by third parties that use the unsafe package. Is there any? Yeah.
Are you
this
talking
way sounds
about
much better. Is there any plans to actually improve that, or what is the problem there? Effectively, why hasn't it been improved?
There's a very strong desire to not cheat in the standard library. Ideally, nothing would have to import unsafe, but obviously there's some exceptional situations. We don't want to reach for unsafe for performance reasons. That usually indicates that the compiler could be smarter, the code generator could be smarter, something else. So rather than reaching for unsafe and cheating, or writing it all in assembly and cheating or whatever, we'd much rather be able to write regular Go code that's safe, that's checkable, that's easy to read, and have the compiler be smart enough to make it fast enough.
Yeah, no, I know that. I understand that. That's always been the kind of your official stance, but it still is. I think it still is a problem because JSON is the input tracker of the web, right?
Sure.
So if someone writes something that is 10 times faster than the standard library,
Yep.
you know,
Then use that.
Yeah, use that.
You can use that if you've got a specific use case, and then as long as its API is similar enough, hopefully you can switch back to the standard JSON package when it gets fast enough. And then file a nice bug report or an experience report to indicate the difference.
yeah. So my question is, when is it going to get fast enough?
Have you filed a bug for it?
So part of the reason is that the JSON package has some constraints. For example, it buffers all of its output and then flaps it out in one time. That can be quite hard to generate, but that's not something that can be changed because of the actual API of the JSON package.
That was one of the first interesting packages. I mean, truly different packages in the Go library. It was based on the XML one, which was kind of the first one like that. And when those libraries were designed, we didn't know as much as we know now. I'm sure if we were starting over from scratch, we would have a slightly different internal structure. It would probably be a lot faster, and so on and so on. But again, you know, this thing we're coming up to, it may be that a slightly different API is the answer to the performance problem, and that's the kind of thing that would make a great experience report. Tell us that JSON.Marshall is too slow, and here's why it matters. It's exactly the time to do it.
Yeah, to amplify that, people complained a lot about the speed of JSON.Marshall before we moved to growable stacks, because the JSON encoder does recursive. It's a recursive function and would always fall across the stack boundary. So no matter what stack size we chose, no matter like how many frames we pulled out or added, there would always be some pathological edge case. Like the Go one test would flop around by 30%, just depending on moving the line. That wasn't fixable because that wasn't fixable until we had growable stacks. But to your point, I don't think I've seen, people complain bitterly about regex not being as fast as PCRE, but I've not seen a report about JSON is too slow for 3 years.
I'm going to make it your fault. It's your fault it's slow because you didn't tell us it was slow.
Can I ask another question because people aren't going to answer questions? Is there any telemetry in the Go tools? As a language researcher, you know, having compile errors logged from the Go tool or something, is there telemetry in the Go tool? And I know there's a lot of telemetry in Google around rules about nice code. But is that available? Is that something that would be looked at?
We actually, you may remember this, I think we had telemetry early on in that respect, and to go install, telling us about things like what people are installing and stuff like that. But after a very long, heart-rending think, we decided it was probably better for everybody if it didn't look like Google was just snooping on you while you were building your code. And so we deliberately did not put anything that reports back to Google about what you're doing with Go. That was a conscious choice. Now, I know as a researcher, getting the data is always nice, but maybe you could suggest to the community or somebody to make that stuff available. But I don't think it's our role to collect that data for you. I think that would make a lot of us very uncomfortable. Does that sound right?
So type safety is quite helpful. That's one of the big things about using a language like Go. Has there been any thought to adding a not nil type expression so that you could function?
This is on the list of features that people suggest but are not not suitably justified by the problems that they cause in real software. I fully empathize with the idea that, you know, the nil story in Go is a little funny. There's people who've talked about the difference between, like Dave had a blog post about the two kinds of nil. It was actually multiple kinds of nil that day. And he's got a fair point, but you've got to consider what it means to change it. And I'm not saying it could change or that it won't change. I'm saying we're far from being able to decide this needs to get fixed. Again, it all comes back to the thing about experience. There are a lot of problems that Gophers have early in the use of the language that seem like they're just wrong. And they may well be wrong, but whether they're wrong or not, we learn how to cope with them. The question we have to ask is, where are those problems actually just being covered up? Or are they fundamental? Where do they cause problems, and what should we do? Now, there's a bunch of stuff around how nil works, there's stuff about how error handling works, there's stuff about constant types other than integers and strings, whether shadowing, how range loops work. See, I've thought about this. The way, all the different ways to declare variables, why you need keywords at the top level within functions, and so on and so on. There's a long list of things that are clearly not quite right, but that doesn't mean that we obviously are going to change them. We need to base the decision on what we're going to change on what really matters and who the audience is, which is why I come back to this point about what matters in production. That's a really good reference. So I'm not trying to dismiss it. I think your concerns are valid about it. But what should we do that actually really helps everyone?
Yeah, my experience comes first. Since I started my double degree with JavaScript, not Go anymore, and so JavaScript AS compiler, loaded compiler has a null type, and I found there were a lot more types that didn't get to runtime because of that. So.
Okay. Can I experience reports?
Yeah, can I throw something here? My experience coming to Go was the last language I touched before that was Java, and I think, again, this is just my personal belief, that the set of people who are deathly afraid of nil are closely intersect with the set of people who use Java every day. I'm not saying that void nil pointers are not a problem in other languages, but they do seem to be very particular in Java programs because nil is used as an error. Nil is used as essential for it didn't work. I have to return out of this function. What can I need to give you something, so I'm just going to give you nil. And I believe that string, for example, is a nillable type. So everything we do with a string, the error for I couldn't do that is I'm just going to give you a nil string back. Just re-emphasize this is my belief. I'm not representing anybody else's, but coming to Go where we don't use nil as an error. We have this specific error idiom. We don't use nil as the catch-all for like I couldn't return you a real value, but I have to give you something because that's what the function signature says. Nils aren't as big aren't a big of a problem as they are in Go, as they are in Java.
This is also another interesting situation where an experience report is more helpful than a suggested solution because another solution to the same problem is not to change the language but to improve the tooling. Some of the important static analysis stuff that Go has grown over the last 3 or 4 years can do some remarkable things of tracing whether you could possibly get a nil value at certain points or stuff like this. It doesn't have to be baked into the language. It can just be a static analysis tool to discover problems. Certainly security-related problems are great for this because they can often be heuristic in nature. And they can trace through a lot more than what baking it into the compiler that only sees 1 bit of code at a time can ever possibly do.
It is, however, grown to solve the halting problem, but you can make a lot of progress. But there is a real point Dave makes here, which is sometimes tooling is the answer. Tooling also has the advantage that it doesn't break any code to have better tools. You don't have to change how you work, you don't have to update your software. The tools can handle that. And tools are, as I said on the slide, Go is not just a language. There's a lot of pieces to it, and we need to consider all of them when we think about answers. That said, knowing what I know now, if it was 10 years ago, I think we would have thought a lot harder about non-nullable types than we do.
You mentioned with regards to Go 2.0 that it's going to be based on experiences and experience stories. What's the decision what's the decision-making process going from experience, user stories, experience stories into the features, particularly when they're not mutually exclusive?
The question is, how do we go from experience reports to Go to? And I think the answer is we don't know yet. But the community is going to be involved. We're going to be socializing it all. Look at the mess that was made with type alias until the community was properly involved in that conversation and how that all worked out. We learned a lot in that process. And I think that if experience reports generate the right kind of response, then we'll know that something has to happen. The community will have a voice, I promise you that. But we're very early in the process now. We've only been talking about it for a month or so. And this is going to be a multi-year project. Incremental, difficult, fractious, and who knows where it'll go. So I can't say what it is going to be yet, but I can't promise you, but I sincerely hope that you will be very happy with how this works. We have lots of examples of how not to do it.
Some solutions also come in the least expected ways. I was chatting with a colleague earlier this week about the monotonic time change in Go 1.9. And he was remarking how elegant it was, and that if he's quite a senior engineer here, if he was designing this like from scratch, and he realized, well, I need normal time, but I also need monotonic time. Clearly, I have two time types, and that would end up with a much worse API than what we ended up with. So sometimes you can see a problem, see an obvious solution, but it's going to take a suggestion from left field to find a really good solution that works. So I don't think there's a clear path always forward from problem reports to a solution. You were next.
I recently read an interesting post from Dropbox and their experiences using Golang. And one of the biggest problems they described was that a lot of their developers had issues identifying race conditions in highly concurrent code. They described, issues that the tooling couldn't catch. Is there any ideas on how to approach that problem?
I'll just read the question for the camera. Dropbox had a blog post that talked about one of the most difficult things for new engineers coming to Go was building an understanding of what a race condition looks like and how it can manifest itself in your code. Mitch, do you want to step up to the plate?
So, as I said, like we run dgraph and we have pretty highly concurrent code there as well. It is hard to build concurrent code in general, right? Particularly, new folks when they just join the team, it is very hard because I think in this case, Dropbox is coming from Python background and they're used to just thinking everything just runs in serial order. So obviously Go has pretty good tools like Go race detector, etc., which definitely help. You can run unit tests with it, and it would give out a pretty clear report so you know exactly what to do with it. But sometimes that's not sufficient. If you're running in production, for example, you can't just have this race thing run because it slows down the program. I think the best thing that I found that has worked for dgraph has been code reviews. Even though it's not like what we would most want to do, but code reviews are the one by which you can transfer knowledge and bring new people up to speed on exactly how they should be writing simple and concurrent code. And I think it's even a bigger, it is very important when you're writing concurrent code that it be extremely simple and nobody builds smart solutions which they think they might have ported over from some other language. You really want them to write just the basic simple Go code, using channels and whatnot. So that has worked out for us.
Yeah. I think it's several points here. One is people come to Go sometimes because of the concurrency, and they tend to overuse it, and that's often how you get race conditions. You understand it better. That said, they're still very possible. One thing that changed in a recent, I don't know if it's 1.9 or 1.8, I think it was 1.8, was we now automatically detect in the runtime races with the maps. And that's the kind of thing that can come surprising, right? The language actually detects, hey, you've got a racy map here. And those are, I can imagine more implicit automatic detection of races down the road, and I hope there's more of them. And finally, one of the best ways to find races is to run your code with the race detector turned on. As Manish says, it slows you down, but you can do what we call canarying, run some tiny subset of your traffic through it or some test instance, run it, but run your production binaries with the race detector on some fraction of the time somehow. Don't run unit tests with the race detector and declare your code has no races. That's unwise. The race detector is fantastic. It's not 100%, but it's probably 95% good. And make sure you actually use it, not just sort of say, I've used it, and make, do that.
One thing that kind of occurred to me a while back is that you don't know to look for race conditions if you are not expecting them. That's a poor way of putting it, but if you're coming from Python, the idea that two pieces of code can be running simultaneously is mind-blowing enough, let alone the fact that they may be interacting. Like you just have no conceptual basis to visualize, to imagine, to conceptualize what's actually going on here. So in saying this, I want to be really clear that this is not a blame on the programmer. You move to a new country, no one tells you to drive on the other side of the road, because for everyone in that country, they know you drive on the right. Of course you do. Like I've lived here all my life. Of course you drive on the right. So it's not a question of being noob or not knowing the basics. What I'd be interested in is, like Manish talked about code review. I'd be interested in talking about ways that make racy code look incorrect. I always lean on Go format as like my kind of crutch for every argument, but Go code that is not formatted, I mean, not just looks weird, it's hard to read, but is kind of an instant signal to me that the person writing it has not really understood the idea behind Go. Like you say in Python, it's not Pythonic. Like when you see Pythonic code, you're like, what else is waiting for me here? So what I'd be interested in is ideas of how to write Go code in ways that basically it looks correct. It's probably race-free, and if it looks odd or weird, it could contain races. And what that means in practice is a discussion about ownership. You can't have races if you don't use pointers. So where you see a pointer, that like ingraining in every Go developer, where you see, oh, I've been given a pointer to a value. So who owns that? Who could change that on me? Building that kind of mental model, because that's how you construct an idea of how the different Go routines in this program interact.
Sometimes you have to use pointers, but if you see someone setting a pointer over channel and then use the pointer on the next line, that's a race. Right? There's things we can actually detect mentally in code review. I remember the first time I ever really discovered a race condition in code, and how I did not see it. Wow, how could this possibly not work? And it took somebody tapping on me on the shoulder and saying, here's what's going on here. I said, and it was really like, the clouds part of the sun came out. I suddenly realized my life was going to be miserable from then on. But you have to face that it is a part of working in the world. And Go gives you the tools, but it doesn't guarantee that you know how to use it.
We don't need a borrow checker for that, do we? Just putting it up there.
Okay, so Chewy talked about the borrow checker. I've thought about this a lot. Like, I don't want to start a Rust versus Go kind of argument, but my interpretation of this is that the Go model is effectively optimizes for the likely condition. The likely condition is that you're not going to share this value with other people. The likely condition is your values are going to live within a single Go routine. They're probably going to live on your stack because they're just in function arguments. The likely thing is that you don't need to worry about the ownership, the explicit ownership. Whereas it seems to me that Rust optimizes for the worst case. Every single time that you do an assignment or you call a function call, you have to. The language is taking the most pessimistic view that this is going to be concurrent, it's going to be stored, it's going to be shared. I see values in both approaches. But I'm reminded of what Alexandra and Rescue said about the way that to make this working Go in Rust's type system kind of distorted it. He said like a bodybuilder that skips leg days. Okay? There's so much of the complexity of language is dedicated to this one idea, and it's important. Like being on a bench a lot is important, but it's not whole and complete. But Hamish has been waiting for a long time. So You got the mic? Go for it.
Yeah. I was just going to ask about the bits package. You kind of hinted that that might end up changing the compiler and a few other things.
Yeah, it could. The thing is that the compiler knows about some packages, right? It knows about a little bit about runtime, it knows about unsafe, knows about reflect. Does it know reflect? Yes, it does, but only a little bit. Math bits is there as a helper for the compiler to a large extent, but it also makes it possible to write out code that's easy for a human to read. For example, I think the compiler still does this, but anyway, before there was a math bits package, if you wrote out a bit rotate by doing left shift, right shift, and OR and then together, the compiler recognized that and turned it into a rotate instruction. But you had to write all this nonsense to do it with angle brackets everywhere. And when the math bits package came along, the compiler could now say, oh, the math bits rotate, I know what that does, and it generates the rotate instruction. So it helps the compiler. I mentioned the random number generator. The random number generator I'm working on has 128-bit by 128-bit multiplying it. And you can write that in Go. If you write it in raw Go, it goes at a certain speed. With a little help from the math bits package, you can do it in an astonishing 3 nanoseconds on my machine. Still in pure Go code, but using the math bits package to help. And if we roll out this as a default generator, we can probably get better because the compiler can know more about that. We might put more into the math bits package to support 128-bit multiplies and get it down to 2 nanoseconds or 1 nanosecond. Machines are ridiculously fast, and the math bits package is about making it clear how to write code that can really extract every cycle out of the low-level arithmetic in the machine.
Cool. It also acts as a bit of a relief valve to certain types of language changes. Since before Go 1, people were asking for specific types of mathematical operations to have alternate forms, like doing a division where you get both the dividend and the remainder. The question and the remainder. We could change the language that would be confusing to most people who don't expect that. Mat.bits, mat/bits allows us to put it in there and be just as fast for the very rare cases.
Yeah. Getting the carry bit is another one. Yeah.
And just one other quick one. I was going to ask the sync.map, if it's not generally usable, I'm just wondering why.
It's generally usable, it's just not, it's optimized for a particular use. That's, if you're not in that pattern, you should probably stick with regular maps.
Yeah. It's like RW mutexes, you don't want to use them in every place that you have reads and writes. Sometimes using a plain mutex is more efficient, depending on the balance between the read and write operations.
Yeah, just on to another thing, a point to David's. In the day before GopherCon, we had this thing was called the Contributor Summit. There's a blog post on the Go blog, and one of the things that Russ brought up was 128-bit types. Now, if we were going to add them to Go in the kind of straightforward way, it would mean you int 128, 128, and int 128, and then that would open the door to AVX56, 512, blah, 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 blah. Russ's suggestion was, rather than, and of course don't forget, this has a knock-on effect to everything. Now, all of a sudden when you're doing type switches, you now have 2 extra types and 2 more types and 2 more things that can be. It would kind of be this Cambrian explosion. But Russ's suggestion was, there is no difference in memory between an array of 2 int64 or uint64s and that would be how you would model it in the compiler anyway. So effectively the idea is to extend this notion of intrinsics from functions to data types. Like, there are problems with alignment, but alignment is tricky enough anyway, but rather than adding this flotilla of new data types for esoteric AVX things, just teach the compiler to recognize 8 uint64, that's the magic type that goes to AVX. That was his suggestion.
So bringing it back from all the Go2 talk, there's a lot of trains of...
Yeah, green. Oh,
what's that? Flat battery.
The battery's
Okay.
dead. Sorry, the battery's
Here you
dead.
go. We'll swap. Thank you.
So yeah, going back from Go2 and just thinking about the various trains of work that have been going through, like SSA and inlining, and there's all of these sorts of things that have been landing. And there's stuff that's getting explored coming up. I guess, what are you all most excited about or interested to see, which may or may not land?
Sorry, the question is about the 1.9 release in general, about
1.10, 1.11.
What's coming? Yeah. So the question was, what are you excited about in the features for 1.10, 1.11, like the near future? Personally, I'm not really excited about changes to language because I think someone said quite a few times the language is done. I'm excited about changes to tooling. I'm very excited about there's finally some progress on dependency management. There is finally some consensus forming, which is the most important part of progress. So over the last year, I've changed jobs a bunch of times, and I've moved into a bunch of environments and bought Go into them, and I have seen just how hard it is for Go code written by one engineer in the same company to be used by another. There's still too much variation in building, I'm going to say moderate-sized projects. Like when you get up to trying to integrate with Kubernetes, that's big size. But even just moderate size, I'm excited over the next year. There's actually going to be some reduction of that set of choices. People are going to. I keep saying I want the Go format for dependencies. I want the standard that we all just use by default to be there, because that will mean we have about 1,800 developers inside of Atlassian. Not all of them use Go. Quite a few do. You should tune in next month. In the middle of September, you'll hear an announcement. And just remember, that's all ready to go. But what we struggle with inside of Atlassian is people moving between projects. It is so, even though we have very simple language, very straight tooling, but there are still too many bits that change, and especially when you integrate with third parties, which dependency management, how they lay out their sources and go gettable. What I'm really looking forward to is a reduction in that complexity space. It means that people will actually be able to move between teams, because if you can't move between teams, like if a team can't move on and somebody moves in to replace you, then that product's going to be rewritten in another language. So I'm really excited this much more structured approach to solving the dependency management and release management process is coming.
In a way, the dependency management problem was a good, not quite written down, but very much worked like an experience report. Inside Google, where we have one tree, it just wasn't an issue, and we didn't really understand the problem, and it took users saying, hey, we're having trouble, here's what's going wrong, here it doesn't work, for us to finally try to support an effort to get dependency management done right. And I think Dave's right, it's very, very important, but we didn't step in and say, here's how it's going to work, because we weren't the people to do it. We needed the community to tell us. But to get back to the question, Manish, do you have anything?
Well, I was just going to say what I really like about 1.9. I think as somebody like who is writing code which is downloaded by some random people and just run, and they then talk about like performance issues, etc. We really tell them to like do a heap profile or a CPU profile, and if they're running from master particularly, it's very hard for us to know the exact binary that they're running with. And I've spent like I don't know how many hours trying to debug something, looking at these random lines of code which should not underperform, but they do. And turns out I'm just looking at different binary. So I think having symbols inside bprof are like absolutely.
It's going to be fabulous.
Yes, pretty amazing.
My question is about.
I think that the thing that I'm always surprised by is where the tooling's going. It seems like everything's around to some really cool new tool that does something I hadn't realized was really cool and I wanted. Even things that we obviously needed but didn't have, like a debugger, we now have a pretty good debugger. I don't know what the next cool tool is going to be, but I know I'm going to wake up one day and go, holy crap, how did I do without this? And I'm very, very happy with the decision we made literally on day one that tools are going to be part of this language, and we're going to make sure that tools can work with it really well. And I want you guys to build the next thing that gets me excited. I don't want to tell you what it's going to be.
I'm also looking forward to seeing the influence that various Go things have on other languages. Go format was kind of, oh, that's kind of a neat thing. It's kind of interesting when it came out for Go. But nowadays, every second language now has it, and it makes such a big difference to working in everybody. Go popularised it. It wasn't the first one to have it, but it was certainly one of the most popular users of it, and it popularised the idea that you could have an auto formatter that was maybe not everybody's favourite solve, that's only good enough, and it allowed you to build a whole lot of tools on top of it. I'm excited by what other things Go comes along with, not just for Go's sake, but also for kind of raising the minimum bar to other languages as well.
A lot of the other languages that have automatic formatters, though, they put options in, thereby missing the point. You're right that I see tweets probably every day where someone says, I wish I had an X for some X language, and it's really great to see it. I think that was actually an industry changing.
He's asking a question.
Your question, sir.
My question is about the evaluation criteria for what's a good experience report. So how will you decide what ends up dictating a new feature? And as a follow-up, once you have a clear image of what will be done, will there be a request for comments phase towards Go 2?
Two questions there. Number one, what makes a good experience report? And number two, will there be a request for comments phase? Let me answer the second one first, because it's easy. Yes, of course. We'll go through the proposal process, and it'll be very public, and I think we'll have some very, very long discussions about in public in the issue tracker or maybe some other tool before anything gets done. To answer the first one, what makes a good experience report? If you go to the wiki that I linked, called just golang.org/wiki/experience reports, I suggest you go look at them and look through a few of them. And some of them you'll read and you'll say, eh. And some you read and go, that's pretty convincing. That'll tell you what's good, right? What matters is whether the problem is real, however minor it may seem. Is it a real problem? And was the language or the tooling or the libraries or the ecosystem in the way when the problem should have come about? Is it well explained? Is the solution maybe clear, maybe not? The solution is not as important. It's the problem. Is this a real problem that is very clearly explained and worth thinking about trying to fix?
And they don't even have to be fresh problem reports. There's at least one there that's 7 or 8 years old at this point. And we solved that problem in one way, but that doesn't mean we solved it the right way. So if we're going to be reevaluating things, maybe we come up with a different solution for the same problem that's already solved, if it turns out that our kind of solution has rough edges.
50 things I would like to complain about, but I don't want to have a discussion. Yep. Just a lot of things I'd like to change, but it's not up to me.
I'll give an example of what I think a good experience report is, and it starts with the problem that I'm seeing. You have to start from, this is the problem that I'm seeing. Way back in Go 1.0, if you had not set Go path, it would default when you did Go get to putting in Go root. This worked great for all of us who had come from the pre-Go get world, where there was no difference. It was just your Go directory. You had all the stand library and a bunch of other stuff in there that you downloaded. When Go 1.0 came out and we started putting bind releases out there, these weren't owned by the user. So Go root was not writable for them. So the very first thing that would happen is that they didn't do a thing, which like the default behavior was that when you did Go get, you would get a permission error because it defaulted to putting it in Go root. The instant thing that we've all been taught when you have a permission error is just hit it with the sudo hammer, and that just made things worse. And this was something that was made clear to me about spending about 8 or 9 months helping people install Go on IRC, and that was what I used as the basis for my argument to convince Russ that we shouldn't fall back to Go root. Like we should actually make the experience a little bit shitter for us as the people who were building Go from source, to make it a little bit easier for people who were using the distribution that we provided to them. but in telling the story, I'm trying to make the narrative that it starts with the problem, it starts with how does this problem affect people, and then moves on to explaining, trying to convince Russ the problem, and then to the solution.
Not just Russ.
True.
He's not the sole.
Yeah, I'm not trying to make this a kind of David and Goliath type exaggerating for comic thing. But that's it.
So, yeah, I had a question around, I guess, running apps in production, basically. So, we're moving all of our apps to run in Nomad using Docker. And we want Docker because of the isolation, that's why we're not using the exec driver. So, for running Go, the thinking was, well, we don't need to ship an entire operating system, let's use Scratch Docker containers, which is fine, but then sometimes you have to compile without Seago. What I found interesting is for some web server, something I compiled without Seago was smaller than the one with Seago enabled, and I didn't really understand why the binary was smaller. And just like in general, is this the right way to think about these things? Shipping Scratch containers without Seago, and like, is that yeah, are we thinking about that the right way and getting around that?
So there's okay, for the camera, there's several questions there. Well, one is, we want to use the smallest distribution possible, and that means not basing it on Ubuntu or Alpine or something like that. It's just, I mean, Go as a single compiled binary. Why can't I just have that as my Docker file? To accomplish that, normally you need to compile without Seago.